So here we are back inside our editor. As you can see, things are slightly different than you were last here, and that's because I've already started recording the third section. And as you probably have worked out, I tend to record the summary video after I've done the first video of the next section. But as you can see, our game time is working. It was going slow there because I wasn't actually clicked onto the screen. You can switch between civilian and military time, and it still advances. We can speed it up. We can slow it down, and we can even pause it and unpause it at whatever speed it was at earlier. So let's talk about how we get this set up. The first thing we really need to do is I'm going to exit this so I can stop watching it scroll like that. And yes, consider this a little bit of a preview for what we're going to do next. If you go into our blueprints folder, you can see all the blueprints we had before are still here. There's nothing new. Everything I've created for the next section is actually outside the blueprint folder. It's these folders. And we're going to start with our library. And inside our library, we have our library function script. And the first thing we have in here is our game time. And a lot of variables will be calling this up. Our lighting calls it up for our day-night cycle. Our HUD uses it via our player state. Our player state has our clock and calendar, which uses it. And the way this works is delta time is passed in through an event tick. And we pass in game speed and game time as variables we create. We divide this delta time by our game speed. This will create what will be sort of our seconds in the end. What we'll use to actually create our hours, not seconds. And we pass through our initial game time. We add these together, and we divide it by 24. And the reason why we divide it by 24 is to turn the value into a representation of an hour. If we did this by, say, I think it's 3,500 is how many seconds there are in a day. I'm doing the math in my head or from memory, so I could be wrong here. If you did that, though, this would be a really fast moving sort of clock. So using an hour makes a little bit more sense. The return value, the whole value, so if this number is, say, 25 comes in here, it's 25, the return value will be 1. That's the number for the remainder, and that's passed through as day count. The remaining part, which will be 1 over 24, gets passed through as part of our game time. So it goes from here. So this gets called into many functions. The main one we need to look at when we think about our game time, however, is our game state. So if we pin this back up here, it gets called in our event tick, where we pass through our delta seconds. We put in our game speed, which is set to 150, and our game time, which is actually defined up in our player sort of. It's actually defined as 0. We set it for the first time in our event tick. Sorry, I was thinking about the game speed actually when I was going up towards the event begin play. So we set our game time here. We also set our day counter here. And then we pass this information and we go into our clock. And then we update our clock every tick. We update our calendar every tick. Arguably, because the calendar only updates after 24 hours in game, we could create a thing in here. We unhook this and say when we hit 24 on the clock, trigger the calendar. It might be more an efficient way to do it, just as an experiment you might want to try on your own. Let's go into the clock for a second and see what's happening. So if we're here on the clock, the very first thing we set is seconds. And the way we do that is we take our game time and we multiply it by the number of seconds in an hour. And the reason why we multiply it by the number of seconds in an hour is, remember, game time is represented by an hour. This information is then passed through to this division with whole and remainder, and we divide it, oddly enough, by 60 to represent an hour. And the reason why we have to both turn this into a second and divide this is because we need to make sure the seconds don't go over an hour and that we're actually counting our seconds. The seconds get divided. Anything greater than 60, that return value gets passed turned into a minute over here. We'll get to that in a second. But say this is 61. What comes through then is that 1 second afterwards gets turned into the remainder value is 1. It isn't 1 over 60. It's literally just the remainder value gets passed through as 1 second. And that's set here. If this is less than 60, whatever the amount is gets passed through as, again, a second. This will update over and over again, multiplying it. So whatever's coming through here always gets really kind of turned into a second. If you just dropped this out or somehow got count up to 1 somehow every second and put it through here, this part wouldn't work right. The remainder would actually be 1 over 60. But because of what we're doing here, it comes out to be a value that will represent 1 when it's, divided. A remainder value of 1 will actually be 1. So I said 61 in my example. It actually isn't 61 that's passed through here, but that's a different. But you can work the math out on your own and get what I mean. Just a rough idea. So that remainder value of the minute is passed through here as a integer. It's then converted back to a float. And we check, is it greater than 60? So, if it isn't, any value that is, larger than 60, after you divide it, the remainder that comes out is passed through as our minute, or any value less than 60 is passed through as a minute. The return value then, so we set our minutes by the way, a return value, which is a number of hours, comes out as an integer. We turn it into a float and divide it by 24. And we work with this in the next little calendar bit. And then we set any remainder from that division as our hours. And then we set our game time, which is storing our hours and seconds and minutes that we just made. And we store them in an array. Doesn't matter what order you store them in, you just have to know the number associated with each one. Because when you call this up later, you have to know the number you need to call. This information is then passed on through an interface to our HUD, which we'll get to in a second. If we return back to our event tick, we then go into our calendar, which operates much the same way. We come in with a preset day. I set this at February 14th, so this is 14. And we add in our day counter, which we default to 0. So the very first time you load it up, it should have whatever you put in here, which will be 14. As that day counter goes up in our event script over here, see, remember, we're actually not counting it here in our clock. We're counting it as it comes out of our game time, our set game time. We then get the day counter to go up, and that will add 1 to this. We then check, is the value of our day greater than the value of the days in the month? And we pass in our month from what we set in a second, and we pass in our year from what we set in as well in a second. And we'll get into it. These are just variables we've created. Now, if this is false, it's just going to go check to make sure the month is less than 12, and if you're not updating the month because you're not updating, or you're not resetting the days because you're not gotten past the number of the days in the month, you're not going to really reset the month, so it'll probably just be a false there. We're not going to be greater than 12 months, and we just set our day and time. But if the value of our day is, say, 32, and there's no month with 32 days in it, at least in the Gregorian calendar, we then hit this true statement, and we come up here and we reset our day to 1, and we then add 1 to our month, updating our month variable. If then this month update is greater than 12, then we reset our month, and we just add 1 to our year and set our year. And then again, we store this in game data, or game date, sorry, and we store it in an array of day, month, year. Again, it does not matter the order in which it is done. Just know what number is associated with each one. And like before, we pass this through our interface into our HUD. So if we go back to our event graph, let's go up to our event begin play for a second. We could do a reference cast, so we can call up the HUD as we did, because we have our player state in here, or controller, since we are in our player state. We have our controller reference. That's how we call up the HUD and the clock and the calendar. And then we set the default clock. This is just to make sure that everything works right. And I'm going to just make this a little bit neater looking while I'm here with you guys, because I can do that. Sorry, just want that part. It still didn't work. There goes me trying to be neat and fast about this. So we're just resetting it here, and we're making sure that it understands that minutes are going to be divided by 60, because our hours are what we've passed through down in this. So hours are how this is already working. Our minutes are 60, and I could put seconds here. I find it's easier to use hours and divide it by 360. Add it together, that will give us our game time. And the reason why I find this easier is I might want to set a unique time, and trying to get the seconds to work correctly is not easy. It is simpler just to pass through the hours and not worry, and start at a whole minute and not worry about the exact second something happens or the game starts. And then again, we set our game date. This is the initial time we set it. It gets updated every tick, though, in that tick. Pardon me 1 second. I take a quick drink. Okay, sorry about that. Now, after that, we set our default game speed and our game speed itself. This is simply done to ensure that there is no issue. And if you want to see what I've written under there, it's just literally a note to myself on what the time is. So our default of 1 in here, for example, will make a 1 second equals 1 hour. If we put this at 60, 1 real second would equal 1 game minute. If you made this 360 K or 360, then every second would be a second. At 150, the value I've chosen, we now have it as 1 real hour is 1 day. If you want to go really quick, 2.5 will turn 1 day into 1 minute. If you want to set the initial stuff this way, you need to set both these values. So you need to set default game time to something different if you want it to start at a different clock. I would also change game speed, so when you call it later on, it doesn't have any issues. But this is just to initialize our game speed. The actual data for game speed comes in through here when we do our event tick. And if we need to update the game speed using the interface, or using the HUD, it's updated through this. So that covers our game state BP. Excuse me, sorry about that. And let's turn to our HUD. But before I do that, I'm just going to open up our 2 enums we made, just so I can have them as a quick reference when I need them. And actually, I'm just going to do the references right now. In our enums, we have every month. We start with a blank just because, 1, I was taught to start with a blank, and 2, so that we don't have to worry about adding an extra minus in later on. Oh, that's lovely. That reminds me of that little pop-up. The reason why you need to turn off your go away. Sorry. The reason why you need to turn off that autosave, and I know I still haven't done it, it's popped up once already, I think, is simply because I have a new test file for this, to give you an idea of where this is going to go. I had Windows randomly update, or restart on me due to an update, that autosave. Yeah, we're just going to cancel you. While it was autosaving. I had to remake the test file. I rant about it actually in the first video because I started making mistakes. I was too paranoid to open up the test file. So literally in that enum I disclosed, the month's name enum. Again, excuse me. All we're doing is just listing the month names. And in our game speed setting enum, I mean, I could have a blank here. I decided to put the pause in. We have our maximum sort of game speeds, where 1 through 5 is changing the clock, and 0 is our pause. Now, it really isn't pause. It doesn't pause the event tick. It pauses the game clock. And this is important because it affects, if we want things in the game to stop doing stuff, we also need to tell it, the game is paused. Stop worrying about the event tick. And I'm going to show you why that's important in the resources section, especially when we're spawning in new resources. It's based on tick. And if you don't get why that's going to be an issue, think about if the tick doesn't turn off and everything is based on tick. If you pause the game clock itself, what's going to happen? If you haven't worked it out, like I said, just wait to that video or give it some thought. So we call these up in our HUD. That's why I wanted to bring your attention to them. So our HUD's in our widget. And our widget, actually, before we even get there, let's go back to our library and then to our interface. Our widget gets our update game speed and our clock information from the state, from the RTS game state to our HUD. So if we go into our HUD, we see we have a nice little translucent box there with our date. We have dummy coded in, or these are dummy codes right now. What is there, or what will be there? So we have a button that will change this from a 12-hour to a 24-hour clock. We have a progress bar for our speed, and we have our speed controls. Let's go to our event graph. So I'm just going to close that out. And in our event graph, we have the button control. So let's start here. Actually, start at the top of the clock at our time. So, our date. So let's go to our calendar functions. We get day. All this is doing is find the day. Remember, it has to have, this is why you need to know the number associated in our game state. Pass that in. Check if the value is less than 9 or equal to 9. If it is, add in a 0 before it. Turn it into 0, 1 through 9, and display it. If it's greater than 9, just display it. And the reason why we want it if it's less than 9 is it only displays a single digit, and it changes the spacing, so it looks a bit weird. We have that 0 in to make the spacing nice. Same idea with the get month, is that we need to know what our game date is for that, or our game date array value for that one. And we pass that in. And then we use the enum. Make sure you have from integer to byte, from byte to your enum conversion, and then you set your enum, and then you go from your enum to string, and that becomes displayed on the screen. And then for year, sorry, I keep closing as I go, same thing. Again, you need to know the value from the game state. You get it, you put it up here, and you get your value. And we have to turn off grouping so that it looks like a proper year. If we go down to the next line of our HUD, we have our clock. So let's go to our hours for, actually, no, it's the order in which I did the videos. We set, our game clock defaults to the 24-hour clock. And so every time the person clicks the button that says MC, well, the first time they click it, it comes in, goes to A, and turns military time off. Because military in our bools, so we can get bool to open up, is set to default. The next time they click it, it comes through here. It's already done A, so it knows to go to B. It does B and resets the clock, which will change our get seconds special and our set spacer special. Our hours get changed inside of here. So again, we get our hours. We check if we're military time. If we are, we simply check is the value under 10 like we did for the day. If it is, add a 0 in front of it. If it is, or greater in this case, not less than. So if it isn't less than, or sorry, if it is less than 10 and not greater than or equal to, then add a 0. If it is 10 or greater than, don't, and then display it. The simple reason for this is because we want to just get our clock out correctly. We want to, have the spacing the same, consistent, 2 digits on screen the entire time. If military time is not set and this is false, we check, is the hour value greater than 13? If it is, just like a civilian would do, we subtract 12 from it, or anyone else dealing with the 24-hour clock, we subtract 12, and then we get our new value, and we pass it through. Because we know this value is going to be greater... Ooh. There might be a bug here, actually. I will have you guys double check that one. I haven't looked at the civilian clock. And in fact, what I'm going to do right now while I'm sitting here looking at this logic, let's just test it, make sure there isn't a bug. I'm going to just up the speed for a second there. Actually, you know what I'm going to do is I'm just going to go back into our HUD for a second, and I'm going to go into our game speed control. And I'm going to change this last value. Wow. I'm actually glad we're here. So this is wrong. That should be 0.5. This should be 0.25. So make sure this is all right now. Yep, okay. So we're actually going to set this now to 0.025. It would really help if I hit the right keys. And I'm going to hit play. Actually, I'm going to hit compile and play. I'm just going to speed that up for a second. You can see the sun's moving as a shadow on our nice tree that we'll get in the next video shifts. Oh, sorry. Actually, it's not an error. I was overthinking it. Okay. So what I was overthinking was, I said we always want 2 digits on screen. This is hours. We don't really care if it's 2 digits or not. So that's fine. We want to check if it's greater than 13 or not. If it's greater than 13, subtract 12, just like anyone else converting from a 24-hour to 12-hour clock. If it is not, we want to make sure it isn't midnight, because that's a 0 value. If it is midnight, if this is not midnight, continue on and set as normal. If this is midnight, then we'll hit false, because this is not equal to. and we'll set that to 12. And again, set and display. We then get our minutes, and again, we're doing much the same here. We're passing in our game time. We are setting our minutes local. We're checking, if it is a single-digit value or not. If it is single-digit, in this case, yes, I reversed the logic between greater than and less than between hours, minutes, and our day. If it is less than or equal to 9, then we add a 0 in front of it. If it isn't, carry it on and display it. So the next thing we have then, if we go down a line, is our progress bar and our buttons for the game speed. While we're here, however, I'm just going to reset that to the correct value of 0.25, or at least what I want the value to be. Again, you can have any value here. Your default value should always be in the middle, and it should be 1. But, the values either side of it, so the 1 and 2 and the 4 and 5, can be whatever you want. The 3, as the center value of the actual valid speeds, should be 1. And the 0 should always be a 0. That's because it represents our pause. So if we go back to our event graph, I'm going to just close out everything else, and we hit increase speed, we check, is the game paused? Well, if it is, we just want to unpause the game and return to our sort of current, we want to return to the speed we were at before we paused. That's all that's doing, and it's setting the timer. And again, that's an enum, so remember this is byte to the particular enum, and then we plug it into the enum here, which we've set in our input tab over there. And remember, this calls through to the HUD here, which then calls back to the interface, which from the interface, the interface sends that information on to the game state, which triggers that little bottom row I pointed out towards the end. Okay, so if it isn't paused, what we want to do is we want to increase the game time. So we're just going to add 1. That's all that does. We could have done, plus 1 here, honestly. I'm not sure why I didn't, to be fair. And then we want to clamp this. We don't want to go above 5. We don't really need to worry about the minimum. I mean, we do for the decrease speed. We then set the speed setting based on that, and we pass it through to the game settings, which updates inside of here. It just checks what setting we're setting to set this to. If we are at 3, and we hit the up button to go to 4. So I'll go from here to here and increase the speed. The decrease does the exact same thing, except for that add 1 is turned into -1, and here the maximum value doesn't matter. The minimum value does. Literally, it's the same code, except for that one node is changed. Next, we have our pause button. We check if it's paused. If it is paused, then we resume the game speed we were at before we hit pause. So basically, it's hit pause to turn it on, hit pause to pause it, hit pause to turn it back on kind of thing. So is it paused? If it is, then we get the game speed that it was at before we hit pause, we reset it, we pass this through to that function, and we unpause the game, at least as a boolean there. Now, if it isn't paused, the first thing we do is we store the speed the game was at when we hit the pause button. This only happens when we hit the pause button, not when we decrease into a pause. When that happens, that's what it's called up here, it then goes on to set the speed to 0. That's passed to a byte to a particular enum, our speed multiplier enum, and that enum is passed through into the function, and we set pause. Now, in terms of our display, what's happening is all it's doing is it's getting the game speed setting, turning that integer into a float, and dividing that float by 5, because we have 5 valid settings. We want 1 through 5. 0 is not a valid setting for the actual speed, so we don't want anything to show on the graph when the game clock is paused, and the return value is displayed. That is quite literally everything that we have to do. Now you'll notice below this file that there is actually a zip file that you can download that has all of the textures we're using, or all the meshes we're using for the next part. I did get them done in time. I made this horribly ugly tree with this horribly ugly leaves, and I'm actually more proud of the rock. But yeah, so we've got things in, and you were free to use them. I do have a README in there because there are some text image files that I've used for icons that I didn't make. They are open source and public to use. As for the FBXs in there, the object, the tree and the rock, feel free to use them in the tutorial. If you want to use it for anything else, I would appreciate being contacted just so we can discuss some things. And there's that autosave. I am working on getting a better recorder. I have a little bit of a rant about it in the next video. So if you have any suggestions for a good recorder that works at, 1080p or greater, that works with the YouTube and will capture, these little pop-up thingies, please let me know, because that will make my life so much easier. That all said, please drop any comments. Let me know what's going on. I want to give a shout out to Flex for his comments on an earlier video where he's contributed some really brilliant ideas in terms of smoothing out the movement of their camera. So again, thank you much for that. I do see this as a sort of learning hub where we can contribute together, we can talk, we can build this RTS sort of thing together with various little components. I am really thankful for all you guys for adding more comments and talking to me about what you want to see in there. It's really useful, especially when it's public, because other people get to weigh in as well or message me with their thoughts about, I want to see this as well. And, feel free to drop a like if you like this video. It helps boost the channel's ratings. It helps get these tutorials out there to people who might not know about the series. And make sure to hit that subscribe button and that notify icon or bell so that you know when the next tutorial is out. And, as always, I hope you have a wonderful day, and I'll see you tomorrow, yes, Friday, in the next video where we create this resource map.